Welcome and welcome back to 3 Inquisitive Kids. This is part 2 of Lesson 2, Flipping Coin. Here's a course outline for this chapter. This is already our 3rd lesson of this entire unit, and we've been starting to learn about probability. Our learnables for today is to learn to use statistics to predict the probability of events, and be able to analyze and solve problems, and understand and master the method of using frequency to estimate probability. So there's actually a difference between frequency and probability. When a coin is tossed, it will result in 2 different ways. It's either going to be heads or tails. Do you think both events have the same probability of happening? People have been coin tossing throughout history. The following table is data from coin toss experiments performed by some historical mathematicians. So we have Buffon, De Morgan, and Ferrer. And here are some more. As you can see, Pearson might have done this experiment twice. Well, after you plot the tables on this graph, you can see that the stability of the frequency is at about 0.5, which means that heads and tails have about the equal number of chance happening. The more trials you conduct, you can see that the closer the frequency is to 0.5. Whether it's tossing a coin or a thumbtack, like in the last lesson, as the number of trials increase, the frequency of heads or the nail facing up will stabilize around a constant. The probability of event A happening is expressed as P, that means probability, and in parentheses A. Here's some practice. Karen put 1 black ball and several white balls into an opaque bucket and mixed them together. Her friends played a game of drawing balls, and after each draw they put it back. The data is recorded in the table below, and it's run to the nearest hundredth. Estimate the probability of the black ball being drawn from the previous table. Estimate the number of white balls in the bag. Feel free to go back to the video and look at that previous table. On this table, in the last column, we have 1,000 total number of trials, and then the black ball was drawn 251 times. And so 251 divided by 1,000 is about 0.25. Which means that the frequency of a black ball being drawn is around 0.25. So the probability of drawing a black ball, we can estimate based off of the frequency that it's also going to be 0.25 or 1/4. And we can let x be the number of white balls in the bag. 1 equals 0.25 plus the sum of 1 and x, which means that x will equal 3. So there are about 3 white balls in the bag. So let's break down this equation together. Here we have 1 on the very left side of the equation, because probability only ranges from 0 to 1. Either it's 0, it is impossible to happen, or it's 1, it's definitely going to happen. Or it can be anywhere in between. So 1 would equal 0.25, the frequency of the black ball being drawn, times 1 plus x. 1 is actually that 1 black ball, and x is what we're trying to find. It's how many white balls there are. So after you simplify, you would get x equals 3, which means there would be about 3 white balls in the bag. That's most likely it. There's a chance that this is wrong. The production of ceramic tiles is affected by its firing time, temperature, and material. A piece of fired adobe could result as a qualified or unqualified. They are random events. So here we have a table. We have the total number of fired pieces and the number of qualified pieces. I first want you to calculate the frequency of qualified pieces, accurate to the nearest thousandth. Calculate the rate of qualified pieces, accurate to the nearest 0.01. And if the factory produces 500,000 tiles this month, estimate the number of qualified products. First, we can fill in this table as follows. All we have to do was do m over n. So for 95 over 100, it's 0.95. 192 over 200, it's 0.96, and so on. After you observe the table, when the number of manufactured tiles is greater or equal to 400, so greater or equal to this column, the qualified product rate, m over n, is stable at around 0.962. So you can find the average of that. Therefore, P equals 0.96 is the estimated rate of qualified products. And if we made 500,000 products, we're going to times that by 96%, which equals 480,000 pieces. So the number of qualified products is about 480,000 pieces. This is the relationship between frequency and probability. If the probability of an event is unknown, then the frequency is often used to estimate. So we are actually using frequency to help us estimate the probability of an event happening. The frequency itself is random and cannot be determined before experimenting, and it may vary. So basically, you have to conduct a number of trials in order to find the frequency, and many times the frequency is different every single trial, so you're going to have to find the average. And the probability is a definite number which is not affected by each trial. Class summary. Today we learned about the stability of frequency. The probability of event A happening is expressed as P, parentheses A, and we use the frequency of an event to estimate the probability of an event. The probability of an inevitable event is 1. The probability of an impossible event is 0. The probability of a random event A, PA, is a constant between 0 and 1. I hope you learned something from this video, and be sure to come back for our next lesson.